Warm welcome, everybody, to today's event that will tell you all about the results from the KRABAT project and the automation pilot results. My name is Sophie Wennersten, and I'm the program director for Drive Sweden. And I'm jumping in today for my colleague, Sofia Löfstrand, who is the project manager for KRABAT. Unfortunately, she didn't feel 100% well this morning, so we don't really dare those days to take any risks. So I'll do my best to guide you through this very intense hour we have ahead of us. So KRABAT is a really unique initiative, actually. It is a part of the government's innovation partnership program, the Next Generation Travel and Transport. It has the mission to drive the development towards a shift in the Swedish transport system. The project has in fact been an umbrella for several pilots and demonstrations that have tested shared, connected and autonomous solutions in the real world. And something that we really like to see more of, since this is really the best way to learn about real challenges and opportunities, and also to show what possibilities there are for the citizens. The project is part of the strategic innovation program Drive Sweden, and our vision is that Sweden takes a leading role in creating future mobility systems for people and goods that are sustainable, safe and accessible for all. And we do this with over 160 partners from academia, industry, society, and together we demonstrate efficient, connected and automated transport systems. The next hour, as I said, will be very intensive. We will focus on the progress and the gained insights in the automation tests that have been ongoing for the past 4 years. And we will hear from 5 different speakers. It's the Lars from Nobina, who will talk about the Stockholm Autopilot. It's Faxér from RISE, who will talk about the S3 shuttle tests in Gothenburg. Joakim Jonsson from Volvo AB, automated city buses. It will be Katarina Boustedt from Asta and talking about improved testing of self-driving vehicles in challenging traffic situations. And last but not least, 5G traffic tower tests from Eleonor, Sjödin, Turah from Kista Science City. And today we're almost 300 participants registered, which of course says a bit about the interest in this subject. And you will be able to ask questions, and you can type them in the Q&A function during the presentations. And my colleague, Josephine Darlington, will keep track of them, and she will join me here in the studio. And after the presentations have been finalized, we will get to your questions. So it has now been time to introduce our first speaker, which is Lars Polgren. Warm welcome, Lars. I see you there now in the picture. We are now eager to hear about the Stockholm Autopilot. So I leave the floor to you.
Thank you very much. And also thank you for a great introduction, Sophie. And with that, you can please start the presentation. And before I dig in to the results from where we are now, I'd like to look back a few years in time. 2016 was the first demo in Sweden where Nobina was one part, and this was to show how autonomous vehicles can be used. And this planted the idea for Autopiloten that was started in the beginning of 2018. The first step there was to get approvals with permissions from transport agency and municipality, etc. And pretty soon, in January 2018, we were able to take the buses out on public road. And that was the first time in Sweden, so we are really proud about that. Project moved on, and we acquired more experience from both the shuttles and the people's reaction from it. So in the end of 2018, we were ready to take the next step to do it for real, run autonomous shuttles in public transportation. And with this, we moved to Barkarby. Thank you. How was this project perceived? I will start with PTA and politicians. Barkarby at that time was one of the largest city growing areas in Northern Europe. And in this context, also with the goal to deliver the most modern public transportation in the world. So we got really great support from there. And from a political perspective, it was an enormous interest with both the start in Kista and in Barkarby. I would say that road authorities from all over the globe and ministers have showed a great interest for what we are doing. And regarding the citizens or the passengers, which really is the main focus for this project, the reaction is in general most positive. In the beginning, we had a high rate of users who traveled to there just to test the buses. And over time, this number has decreased to a lower number of everyday users. And with that, I ask for the new slide. Why did we do this project and what were our main goals? To summarize it only with one sentence, it is to accelerate the integration of autonomous vehicles into public transportation. I will not go through them point by point now, but I will say that it's a tick in the box for all of them. If I need to highlight one point that I had hoped even more from, is to wrap up the tech development for the shuttles, and this regarding speed, comfortness, and autonomy grade. If this had increased even more, it should bring a higher value for the passengers. Next slide, please. As I already mentioned, tech development is one part that needs to be focused on, and this especially regarding object detection and not to stop for unnecessary obstacles, like heavy snow, for example. And with infrastructural challenges, I mean the problems that we are operating in a city that at the same time is growing. People start to move in before the roads are already, and this tests the flexibility both for the municipalities and the passenger and the operator. And next slide, please. I will not be too long, and I want to summarize this really shortly. What will happen in future and what do I hope for? I am sure and I hope that the number of AVs will increase and the mobility and transport overall must change. So keep on the testing with demos, but important to point out with realistic expectations. So open your eyes for how mobility needs to change, and this seen both from authorities and PTAs and the users also, of course. So you can leave a car home or don't own a car. And with that, I say thank you.
Thank you very much, Lars, for this interesting presentation. And this was actually the first shuttle pilot in Sweden, so it got a lot of attention. And if we just look, you mentioned here now what you'd like to see in the future, but what do you think would be the focus in a very close future in the development of automated driving, from your perspective?
As I already mentioned, keep on going for autonomous transport systems, but high on my wish list is to do autonomous for real, and with that I mean with no operator on board, and this would, as I see it, bring a more flexible and way of traveling for the passengers. It does not have to be exactly this size of the bus. It can be even smaller pods than this, but this will also make it easier from a business perspective to manage with that.
Mm-hmm. And what's stopping you?
Actually, nothing right now, but keep on going with it and with realistic expectations.
Mm-hmm. Great. Thank you so much, Lars. And you will be here in the background listening to the others, and then I'll bring you back up towards the end for some more questions. Thank you very much. And we are moving on here to the next speaker, who will be Faxér from RISE, who will bring us to Gothenburg. And she will talk about the shared shuttle services. Are you with us?
I hope so. Can you hear me?
Yes, warm welcome.
Thank you very much, Sophie. And good morning, everyone. My name is Faxér, and I'm a project manager at RISE. Should we go to the first slide? Thank you. And today I'm going to be presenting to you the shared shuttle services. However, since I only have 5 minutes to be presenting the 4-year project, there will be some details to be left out. So I'd like to invite you to a more dedicated event for our project on the 21st of May. I will leave the link for registration in the chat later on. If you're still interested after this presentation, go ahead and put your name on the list. Next slide, please. So here I'm going to walk you through the project goals of all 3 routes we have run the autonomous shuttles across the years. First, we start down from the bottom. At the beginning, we were trying out the technology at Chalmers just to see how the technology works out in real traffic situations. And then we moved the test bed to Lindholmen, where we test drive a more challenging route with the busy roundabout, and also under the purpose of testing the new use case, connecting them to a remote parking lot to also the office area. And for the third route, which is the route that we are currently operating now, together with our partners, we're expanding the use case beyond the remote parking lots to a public transport hub. Since the first shuttle arrived at Chalmers 2018, we have been already collecting 8,800 kilometers in mileage, and the project has carried more than 6,700 passengers. And this is the number we got until next month. The shuttle is still running at Lindholmen, and it will be running until the end of next month. So let's see what it will bring us in the end. You probably wonder how the routes would look like. Take a tour at s3project.se under About S3, and you will find all the maps there. Thank you. Next, please. So here's how the route that we're currently operating look like. We're operating from 7:30 a.m. to 6 p.m. between Regnbågsgatan and Hugohammarskaj. It is a loop of approximately 3 kilometers and 4 stops. We have 2 shuttles of model Arma operated by Keolis as part of the public transport bus line, line 56. And you can search for the traffic information about our autonomous shuttles on the app provided by public transport provider Västtrafik, and also receive suggestions to take these shuttles when you're wondering which bus or tram would you take to a certain destinations. And we start to run this shuttle service in the middle of January, and today we even got connected to the Ericsson's 5G network. So on this map, you can see the infrastructure we have in this area, which includes 4 bus stops with digital displays, a base stations for GPS connection, and also a 5G radio site in the area. Next, please. So what are the lessons learned? We know that the permit application takes time, exactly as Lars said before. So spare some time and prepare for the permit application. It takes about half a year for us to receive an official permit from the Swedish Transport Agency for the route that we're currently operating now. And you have to think that is already our 3rd test with exactly the same vehicle model. And the preparation work at site is essential because the evaluation is based on the traffic situation and the environment that vehicle that is going to be operated in. We learned that the impacts from changes of the environment, such as unexpected renovation work on the buildings around or some intentional blocks on the way, could cause problems to the vehicle. As a result, communication with local actors is very important to bring up constructive solutions to resolve these situations. And of course, there are much more that couldn't fit in today's talk, but one interesting thing that we observed in that is that the percentage of people taking the shuttles out of curiosity has been decreasing. And this could be a good sign that people are actually starting to use it instead of just test it. So next, please. So where are we heading? I mentioned that we have a 5G connection to Ericsson's network and 5G network. And this enables not only traffic information to, for example, for the Drive Sweden cloud, but also a connection to a control tower. And this could be the very first step towards driving without the safety driver, which also we investigate in the prerequisites to drive without a safety driver inside our project. On top of that, with the S3 projects, we're also looking into the willingness to pay as part of the important knowledge to build a feasible business model for autonomous shuttles. And beyond this S3 project, of course, we're planning to look into possibilities to use these shuttles in other use cases. For instance, the campus, or even to bring upon another kind of design with more user-centric focus for the vehicles. So thank you for listening to me. And right, don't forget about May 21st. Any questions?
Thank you very much, Anne. Very interesting, and good that you have the opportunity also to invite to a more in-depth presentation about it. So yes, I just wonder if you take this automated shuttles out of the test phase and put it in a system, where do you see automated shuttles or smaller buses? How can they operate in the public transport system?
So technology-wise, I think it works very well as a first and last mile solution as we see it today, connected to the public transport. But a more demand-driven system could make this solution more efficient by decreasing the waiting time, because you all know that the shuttle is not driving very fast. However, there does exist some areas that are underserved by public transport, especially when we're looking at the suburban areas or countryside. But there we might need another type of technology that could, for instance, drive faster, or like using another technology. So I do think this kind of shuttle is, as I said, the first last mile solution.
Yeah, thank you, Anne. And within Drive Sweden, we also have some projects looking at exactly the countryside and rural areas, and see how this could fit into that. Totally different circumstances, of course. So thank you very much, Anne, and I'll invite you back as well in a little while. And by that, we move on to the next project, the automated city buses. Warm welcome, Joakim Jonsson from Volvo Buses, and the floor is yours.
Thank you, Sophie, and welcome to this webinar. I'm the project manager for the initiatives that we are doing on a research level on a full-length bus, 12 meter, within the Volvo group. And my name is Joakim Jonsson. In 2017, I think we started this project and we included as a work package within the KRABAT project beneath Drive Sweden initiatives. And we have three main use cases that we are working with. And I will start from what we have not done so far, presented so far, is bus train, when we digitally connect two buses and drive in a bus train formation. And the benefits of that is that during peak hours, we can add more vehicle, more dynamic on a regular bus line, for instance, for morning and afternoons and so forth. And the second use case that we have was depot processes, where we showcase with a live demonstration in a real depot in Partille here in Gothenburg. We do the whole maintenance flow within the bus depot. When the bus is coming back from the daily operation, it needs to be maintained, it needs to be cleaned, washed, and also safety inspection before the next shift. So we presented to drive autonomous within a bus depot. But already in 2018, we presented our research vehicle fitted with the Volvo autonomous research platform, enabling it to drive fully autonomous. And we presented a feature or function that we call bus stop docking at that time, but it's more narrow navigation. And that is what we will continue this presentation with. So on the next slide, we will find, we want to go deeply more in what kind of benefits will automated driving support do for a driver. How can it improve the environment for the bus driver? And the feature is like that in low speed, the driver can hand over the vehicle to itself to execute a predefined autonomous driving task. And example, driving to a bus stop, do a roundabout, or any driving to a bus terminal or reverse from a bus terminal and so forth. And we think that this is beneficial for the drivers. Is a lot of small accidents happen when they try to drive in those narrow navigations. And the feature is like that the driver continue to sit in the driving seat and can deactivate the system whenever it needs or wants by just pressing the brake. So on the next slide, we want to go dig deeper into this and do a study. So we team up with Chalmers Design and Human Factors that we have previously worked with when it comes to other studies. And we presented a couple of main theories that we want to try out in this, evaluate during this study. And those is, for instance, that the driver can easily more focus on the traffic scenario instead of driving the bus. It can more be a supervisor and be more alert when it's something odd happens. It can reduce stress for the driver. We think that less physical loads, arms, shoulders, neck, and so forth, that did not need to grab the wheels all the time. And a down thing that we can add is the questionnaire the professional driving skills of a driver. That was also a theory that we want to try it out. And also, will the driver ignore the system or use the system so it's not will not use it? So the system evaluation, it's that we team up with Chalmers, that we have interview questionnaires before it start to drive, after a while when they're driving, and after the practical drive. So we have predefined a test route in Gothenburg with 5 stops that they have test drive it, and we do 250 stops automated. And also film the driver inside, watching the body language or movements, shoulder, arms, foots, on eyes. And we are now done with the practical driving with all the driver. So now Chalmers is compiling the reports and also an article that we want to publish in a scientific magazine. So that is what we're doing right now when it comes to study in this field. That was all for me. Thank you very much for listening.
Thank you so much, Joakim. Very interesting. And we talk a lot about the involvement of the end users, and in this case, and the drivers also, as you mentioned. And how many drivers were actually involved in the study? How many?
We have 10 drivers, professional drivers that drive regularly. They have the occupation as a driver. Mm-hmm. And we spent a half day on each of them. They was on 4 hours with the hand of us and try the system and evaluate the system.
Mm-hmm. Very interesting. And the report that you were talking about, when will it be public, so to say?
We will have a draft for review before the summer here, and we think we will release it after summer in end of August or beginning of September, I think. Will be advice.
Great. Then keep an eye out on our website, and you will be able to learn all about the details. And the same for you then, Joakim. Thank you very much. And you will be back in a short while.
Yes.
For some more questions. Thank you. Moving on then to our next speaker, who is Katarina Boustedt from Asta Zero. So we will now transfer to the test track outside of Borås. So the floor is yours, Katarina.
Thank you, Sophie. My name is Katarina Boustedt. I work at Asta Zero as research project manager, and I will speak to you today about a short study. It's almost like a pre-study style that we carried out during the fall. It's called Improved Testing of Self-Driving Vehicles in Challenging Traffic Situations. And on the next slide, we can see a short text about Asta Zero. You may know Asta Zero, the proving ground. In this case, it was the research office at Lindholmen coordinating the project and providing competence in testing and test control mainly. Our next partner on the next slide, Viscando. Viscando, you may know, they produce advanced cameras and related systems, 3D and AI-based roadside sensing systems. So these are cameras that sit in the as part of the infrastructure. And they collect and analyze traffic interactions, motions, and register traffic of all different kinds. And you can see here a traffic situation in the bottom right corner. Our final partner on the next slide is Zenseact. And they, in this project, they brought their competence in the need for scenario-based autonomous driving, I should say, verification and field test environment characteristics. And you can see here moving in the bottom, I hope, a simulation of what the vehicle sees. Now if we move to the next slide, this is my final slide. It is showing a bit about the work that we carried out and what we are planning. We are looking at a road merge, a highway merge, the bottom picture where the red car is merging onto a highway. The idea here is to use the cameras to find if it is possible to use the outputs of the cameras to create and generate scenarios, simulations first, and then scenarios for driving and testing the vehicles. So it is a bit of a challenge. It would be wonderful if it's possible, but it's not really proven. So we have hereby by this KRABAT pre-study, we were able to set some of the requirements for a continuation project, which is what we're looking at here. We noted that we needed human modeling, human driver modeling, and that's where Chalmers comes in the middle there. We also needed simulation and vehicle competencies from Volvo cars, so they are also now a partner in the continuation project. And the purpose, of course, is to facilitate testing of autonomous driving using camera output and scenarios generated from that output with simulations. And then in a future step, to take it onto the test track, but only the tests that are really needed, that we cannot prove using simulations and computer work, if you will. So this was really short about this small study and we are very grateful for KRABAT putting us together in this way. We found that we enjoyed working together, and we also realized what gaps we had in the group. So this work now continues in an FFI co-financed project. Thank you.
Great. Thank you very much, Katarina. Very interesting, and glad to see that you are now moving on as well. And I guess that the knowledge that you gain from, you're talking now about lane merging, but could that be used also, I guess, in other applications, or how could it be used?
Oh yes, we would like to explore a generic method, if you will, using these cameras to extract information on difficult situations that are already existing in traffic, but it could also in the future be used for actually planning the roads. If we notice from what we learn here in different locations in traffic that a certain I don't know, a roundabout, for example, needs to have a different dimension to be more suitable to automated driving, then this could be used by traffic planning as an advice.
Perfect. Thank you very much for that. And the same to you. Welcome back in a few minutes for some questions. Thank you very much. And we move on to the last presentation, which is from Kista Science City and Eleonor Sjödin Turah, who will present the 5G ride project. So warm welcome, Eleonor. We will start with a movie, I forgot to say, and Eleonor will be back in a few minutes.
Connectivity, and in particular 5G, will play a fundamental role for automated mobility in terms of driverless, remotely controlled and automated vehicles, but also in terms of smart, efficient and sustainable transport solutions.
And here we are, ladies and gentlemen, getting ready to hop on a 5G connected, remote monitored, self-driving vehicle.
Telia's role in this project is to provide the connectivity that allows these the transportation, the bus, the car, whatever it becomes in the end, to have all the connectivity to the remote control center, which is the brain power that will operate these vehicles in the future.
Thank you, Sophie. Do you hear me?
Yes, we hear you perfectly.
Great. What you saw is a short film clip from our test with self-driving vehicle connected to a control tower via 5G in Stockholm last year. And it was Alison Kirkby, President and CEO at Telia Company, Jenny Lindqvist, Head of CU Northern and Central Europe at Ericsson, and His Royal Highness Prince Daniel speaking. They, among others, attended our inauguration and joined the test themselves. My name is Eleonor Sjödin Turah, working at Urban ICT Arena, a part of Kista Science City. I run this project 5G Ride together with our great project partners, Ericsson, Keolis, Telia, Intel, and T Engineering. Our common goal has been and still are to enable a safe implementation of fleets with self-driving vehicles. During last year, 2020, we set up test beds and implemented tests in an urban area in Stockholm. It was an area where pedestrians, horses, bicycles, kickbikes, and cars interacted with all the challenges that it means for self-driving car and traffic situations. This was the first time ever the test with a self-driving vehicle connected to a control tower via 5G was performed. And how did each project partner contribute to the test? Well, Keolis, a global bus operator, secured that the project had the passenger in focus and also gathered passenger experience during the tests. Telia rolled out the 5G network. Ericsson developed the traffic control tower. T Engineering provided the electrified and self-driving vehicle. And Intel contributed with an edge node in the vehicle, which uses the AI to analyze the data from the sensors in and outside the car. And Urban ICT Arena provided the project management. So through the rolled out Telia 5G network, the correct and secure information could reach the Ericsson control tower from the self-driving vehicle provided by T Engineering. The information is analyzed and sent securely thanks to the edge node from Intel. And in the next slide, I will tell you about one of our use cases. 5G connected automated vehicles with basic control tower functionality has been tested with positive results. And one of the use cases that was verified was to let the self-driving vehicle drive into an unexpected obstacle, and the vehicle sent a question to the control tower if it could pass the obstacle. In this use case, a high-definition video was streamed to the control tower and comprised object detection to assist the remote operator to take a decision. We noticed that it's not only safe implementation we can provide with the technology, but also an efficient traffic flow and a safe passenger experience. We want to use the traffic tower not only in crucial situations, but also to optimize the traffic flow and avoid unnecessary stops, both for the passenger experience and sustainability. All project partners agreed that tests in real environment is crucial to understand the benefits and consequences of different functions. Let's move on to the next step of our project. We can see that 5G and extended control tower functionality with remote control will be key to enable higher levels of automation, larger fleets and other types of automated vehicles, higher driving speed, safe passenger experience, and efficient traffic flow. This is what we aim for in the near future. And if you would like to collaborate and innovate the future 5G ride, you find our contact details on the last slide.
Great, thank you very much. A great example of collaboration between actors and what that can take us. Could you just say perhaps a couple of words of what kind of driving situation would be the first in a test to control the vehicle remotely?
Yeah, well, in the long term, the vehicle should be able to take all the decisions itself. But until we reach that level, there are plenty of complex situations where the autonomous vehicle needs assistance to take decisions or be remotely driven. For instance, if there is an accident and the vehicle must break traffic rules to pass it, the vehicle must be remotely driven since the vehicles are programmed to follow the traffic rules. But the main purpose in the upcoming tests in this project is not to test the specific situations. It is to understand the interplay between the vehicle, remote driver, and people in and outside the vehicle.
Which is pretty complex in itself. So, yes. Great. Thank you very much, Eleonor. And you can actually remain here in the picture. And I will ask all the other speakers now to join us because now it's time for the Q&A session. So welcome back. And I will also invite my colleague, Josephine Darlington, in the studio here, who has kept track of the questions coming in. But before we dig into your questions, I would just like to hear a little bit about the challenges or obstacles that you might have bumped into, because I guess that in these innovative projects, there are, of course, some obstacles or challenges that you had. Perhaps you could share with us. So I would like to start with you, Lars. Could you say something about the challenge, and just one challenge and how you overcame it?
I already thought of two of them.
Yes.
I will do it so quick.
Yeah.
One major that I also mentioned was, of course, the approval from transport authorities, from transport agency, to run on public road. But when we overcome that, it is a problem with the technology in the vehicles, that they can't run autonomous in complicated traffic situations, and this needs to be better to see a real use case for the shuttles.
Mm-hmm. You can take the other one as well if you want.
I stopped there.
Yeah, okay. Then I would like to bring in Joakim. Can you share with us something that you experienced along the way?
Yeah, the research platform that we use to drive autonomous within the bus is from our truck side of the company. And as long as they're not damage to goods, they can drive quite rush. But we have, for instance, human passengers in the bus that's standing up and so forth. So we need to try more dynamic and more smooth. So that was the first thing that we need to consider and take on us when we introduced the autonomous bus, to have the actuators working in another way compared to what we have on other product solutions. So that was the first test that we need to solve, and I think it was so really good with our engineers in a couple of hours.
Mm-hmm.
To speak.
Yeah, okay.
Yeah. So that is one thing that you need to consider and have humans on board at least. That not
exactly.
everyone. Yeah.
So more of a technical character. Are there anyone else of you who wants to share something that you bumped into? Eleonor, for example.
Yeah, well, of course, there's many areas one have to look into before we can implement the autonomous vehicle. But what we saw, that we need to adjust some setup in the 5G network, and I don't think it's a difficult issue, but we have to look into it.
Of course. Okay, thank you. Maybe we should dig into the questions from the audience, since we don't have so much time.
Yeah.
So, Josephine.
Great. We will start off with Katarina. You mentioned a lot of interesting partners you're working together with. What are the future plans? What are your dream partners to get to work with?
Oh, sorry, it was to me, yes. Yes, well, this year we would like to develop an extended functions of the control tower to secure the journey with a checklist, a kind of health check of the vehicle and the route. And we will also work on passenger safety, like identifying if someone is assaulted or gets sick on board. And we will test this together with the vehicles that T Engineering will contribute with. But we also would like to collaborate with several other vehicle manufacturers to get the possibility to test with different types of vehicles.
That's great, thank you. And Anne, we have a lot of questions that have come in regarding the S3 shuttle. Would you like to just begin with the question, what are the main benefits you've seen with working with 5G connection for the bus? Has it really defined the possibility for their operation, or could you speak a bit about the benefits?
I would say it's still quite early to drop this conclusion what the actual benefits are, but we are testing to connect the vehicle to the 5G network. As currently, of course, it's a big improvement for receiving the information about the shuttles. So we will get much more accurate information for the shuttles, and also to step towards the control tower scenario, because that's a lot of you probably are working with control tower and ICU, so that's a big potential for us to go towards the scenario where we don't need a safety driver. So I think that's like, I wouldn't say I know exactly what the benefits are today, but I would say it's definitely building the backgrounds or building the steps towards the scenario where we can drive driverless.
Interesting. So something to discover moving forward as well then.
Absolutely.
And share experience with the 5G ride.
Of course.
So we have a question for Katarina and Asta as well. Regarding partners, you also mentioned many different partners you work with together. What are the next steps there and new cases?
We have just started our continuation project, and we're working with the Chalmers on the behavior models and with Volvo cars on the simulations. Those are the new partners that are coming in. We would want to come in contact with traffic planning, like City of Gothenburg or Trafikverket, maybe to hear their opinions. We're trying to find typical situations that are repeated, if you will, across the nation. And Gothenburg right now, with all the construction going on, is not very typical, unfortunately. So it would be very beneficial, I think, to start a discussion there to see what situation the road owners, if you will, are interested in.
Exciting. So many new cases to explore then, sounds like.
Yes.
That's great. So, I mean, we have lots of more questions.
Yes, I mean, yes. No, bring them on.
So, question to Joakim, which has actually come in twice now. What is the time plan to get this autonomous electric bus on the road?
This depends on which road you're meaning. With the public road on mixed traffic, that is the hardest thing to solve. And we will start with maybe a more closed road that's only a bus rapid transit or something like that, dedicated road with some boundaries, so other traffic cannot be able to drive in that lane. And it's hard to tell when that can be possible. We have a lot of initiative within the Volvo group that we are working with right now, and it's more on confined areas that we see that is more possible right now. But as long as the technology increases and so forth, it of course can be doable. So I cannot say a year or when it can be right now, unfortunately.
I'm guessing the big when is the $1 million question we're all looking
Exactly.
into. That's great. Thank you, Joakim. And Lars, the next question is to you. Do you have any pilots planned on the countryside? So, for example, a 70-kilometer country road in rural areas.
We have looked for opportunities on the countryside also, but one of our main goal is, of course, to increase the speed. As I see it, the first step will be like 40-50 kilometers per hour on like a BRT road where most of the lanes are dedicated. So we start from there, and of course that is also on my wish list, but I think that will be after when we have done the 40-50 kilometers per hour at the BRT route.
Great, thank you. And they keep on coming in here.
I think you should keep them coming.
So back to Eleonor and 5G Ride. There is a question regarding did you perform any detailed analysis of the passenger experience riding the autonomous vehicles?
Yes, well, since we have the pandemic, we didn't have as many passengers as we were hoping for, but some at least. And actually, all of them felt curious and safe and looking forward to until we implement the autonomous vehicles in urban area.
I saw that Prince Daniel, he really liked it.
Yes. It was great and an honor to have him on site.
Very. So I'm thinking this question could also be relevant for more of the demos here. Is there anyone else who would like to comment upon?
Absolutely.
Yes.
Yeah, I can comment on that because we also did a very we have been doing very thorough user analysis throughout the S3 phases. And what we can observe right now is, of course, due to the pandemic, the number of passengers are decreasing, of course, unfortunately. And we also have to limit the amount of people that can be in the vehicle at the same time. But what we are observing is, of course, like people are generally feeling very safe and curious about the technology. But what we want to see more, or at least we were hoping to see the regular users, because of course you take the shuttles out of curiosity from the beginning, but then it needs to be incorporated into your daily life. So you have to use this shuttle as part of your transport method, so to say. That's why we are testing. We're hoping to see this shift. We're still not sure if we're going to reach that goal, but at least we're start to seeing that people are taking it more on not only because they're curious about the shuttle, and this is a very good sign, I would say. But of course, like we are hoping to receive more passengers and to be able to talk to the passengers.
Of course, I think we're all hoping for this to be over very soon for increased trials.
Yeah, let's keep our finger crossed.
Definitely. So I'm thinking we have another question here regarding to obstacles in achieving a green transformation of the urban planning and really the potential in connected automated vehicles. I'm thinking maybe we could open this up, for example, to start with Lars. What role do you see cabs playing in the green transformation?
Wow, that was a large question to go all over to the green transformation. The first step, as I see it, is to make the public transport or shared mobility solutions as so good so people let their car stay home or don't own a car anymore. And to achieve this, I think one important milestone is so that you really see use case for the autonomous vehicle as a passenger. And I totally agree what you said before, Anne, with the pandemic, but that can also be good in that way that it sets higher demands for what we need to do, for example, for developing on-demand solutions. So you feel that, okay, it feels convenient and safe for me to use this vehicle, even if it's public transportation.
Thank you, Lars. And Joakim, would you like to comment a bit on this connected to your future idea?
Yeah, we have buses that drives electrically since a decade back, I think over 10 years. So I think on the green path we are there right now, and with adding autonomous driving, I think we can drive it more efficiency as well, since it drives more accurate and representative all the time. So I think it's a huge benefit for the environment to drive autonomous as well.
Thank you. And Katarina, Asta Zero's role in creating the prerequisites to get these on the road, would you like to comment a bit on that?
Yeah, I think that what we can help with, not being vehicle suppliers or manufacturers, is really to make sure that these vehicles collaborate with each other and with the infrastructure, to make sure that once these vehicles are on the road, that they move smoothly and we don't get a lot of queues and problems. As we know, the traffic will be mixed for a very long time, and then it becomes really important to work with driver behavior and the modeling that I described earlier. I think that's where we would fit in.
Thank you. So one more question, or
I think actually time has run out. We've learned, that we need to have a couple of minutes before everyone should jump into the next meeting. So I think that we will need to round this off, even though it's really interesting to keep discussing, of course. And I think it's obvious that the interest in the subject is really, really high, and we need to continue. We hope to see more of these demonstrations in real life, because that's really, as we've heard today, how we learn. It drives innovation forward in Sweden. We learn about policy development that needs to be done, what is demanded from the society. We challenge the business models. We learn from the technical perspectives what needs to be developed and challenges and so on. So from all these perspectives, the best way to learn is really through these types of demonstrations. So the project, the KRABAT initiative, will be finalized during 2021, and you will be able to find the reports continuously during the year on our website. So keep out for that. And by that, I would just like to say thank you to all the speakers and to the audience that have been so active in writing questions. And yes, keep up the good work. And thanks, and have a great Wednesday. Bye-bye.
Bye.
Bye.